So back in 2017, a few researchers at Google dropped a paper that didn't just nudge AI forward, it completely tore up the rulebook. Today, we're going to break down that single paper, the one that really laid the groundwork for the entire generative AI revolution we're seeing right now.
And the title was almost deceptively simple. Attention is all you need. But don't let that fool you. That one powerful idea would end up replacing decades of old methods and basically kickstart the modern era of artificial intelligence.
To really get why this was such a huge deal, we first have to understand the problem they were wrestling with. What was holding AI back? Why did it suddenly need to pay attention? Well, the core issue was a really big limitation in how AI processed information. You could call it the sequential bottleneck. I want you to imagine trying to understand a whole paragraph, but you can only look at it one single word at a time, in a strict line. That's pretty much how the top AI models used to work. They'd see one word and then just hold on to this kind of fading memory of the words that came before it. See, the big models back then were called recurrent neural networks, or RNNs, and their most important feature was also their biggest weakness. They had what the paper calls an inherently sequential nature. Information just got passed down this long, slow chain, one word at a time. And that created two massive problems. First, it was just slow. You literally couldn't process the 10th word in a sentence until you'd finished with the 9th, so you can forget about doing things in parallel. Second, by the time the model got to the end of a long sentence, its memory of the first few words was, well, pretty fuzzy. Trying to connect the word it back to something mentioned paragraphs earlier, nearly impossible. So the authors of this paper came along with a totally different idea, a complete and total break from this one word at a time approach. Their goal, and they said it right there in the paper's abstract, was to get rid of recurrence entirely. No more chains, no more waiting. They wanted to build a new kind of model based only on attention. This was the game-changing question. Instead of reading through that little keyhole, what if the model could see the entire sentence, all at once? What if it could weigh the importance of every single word against every other word, all at the same time? And they called this magic mechanism self-attention. It lets the model, when it's looking at one word like it, to directly attend to every other word in the text to figure out what it actually refers to. This means context is no longer some fading memory. It's a direct, calculated relationship between all the words.
So this idea, self-attention, it became the fundamental building block for the new architecture, the transformer. Let's take a quick peek under the hood. So how does it actually work? Well, the paper talks about mapping a query to a set of key value pairs. But think of it like this. For every word, the model creates three things. A query, which is like the word asking a question. Hey, who here is relevant to me? A key, which is like a label on every other word saying, this is what I am. And a value, which is the actual substance, the content of that word. The calculation itself is beautifully simple. First, you take one word's query and you compare it to every other word's key to find the best matches. This gives you a score. The higher the score, the more relevant the words are to each other. And finally, you use those scores as weights to create a brand new representation for your original word, one that's built from a weighted mix of all the other words' values. But they didn't stop there. They realized a single attention calculation might miss some details, so they came up with multi-head attention. This is brilliant. It's like having 8 different specialists look at the same sentence all at once. One might focus on grammar, another on the meaning, a third on sentence flow. You then combine all of those different perspectives to get a much, much richer understanding. Okay, so that's a brilliant idea on paper, but the real question is, does it actually work? So the researchers put the transformer to the test against the reigning champs of AI. The task they chose was machine translation, specifically translating English into German and English into French on a really tough standard dataset. This was the home turf for those old RNN models. This is where they were supposed to shine. For the English to German task, the transformer got a BLU score of 28.4. Now, that number might not mean a lot by itself, but in the world of AI research, it completely blew the old record out of the water. We're talking a massive leap of over 2 full points. And for English to French, it was exactly the same story, a new single model record of 41.0. The transformer wasn't just a little better, it was in a completely different league. But here is the real kicker. This chart just shows it all.
The transformer achieved these record-breaking results while using a tiny fraction of the computer power. We're talking an order of magnitude less training cost than the models that came before it. Better results for less time and money. That isn't an improvement, it's a paradigm shift. So the results were pretty clear, but the long-term impact of this paper goes way, way beyond just machine translation.
This table from the paper really is the key to everything. For an old recurrent network, the number of steps to connect the first word and the last word grows with the length of the sentence. But for self-attention, it's always one, a constant time. The first and last word can communicate directly in a single step. That's the fundamental advantage.
And this breakthrough, this new efficiency and connectivity, it changed everything. Because they broke free from those one-at-a-time chains, it suddenly became possible to build much larger models and train them on absolutely massive internet-scale datasets. The bottleneck was gone.
And that is exactly what happened. The T in GPT stands for transformer. Every large language model you hear about, every AI image and video generator that's blowing people's minds today, it can trace its origins directly back to the architecture laid out in this one paper from 2017.
This paper really proved that sometimes the most profound breakthroughs come from a simple, elegant idea that just dares to challenge a core assumption we all take for granted. It really makes you wonder, what fundamental bottleneck are we all just accepting as normal today, and what simple idea might be all we need to unlock the next revolution?